Japan's military aviation began in WW2 with aircraft like the Mitsubishi A6M0, famed for its agility and range. Post-war pacifist constitution restricted Japan's aircraft industry, limiting designs to civilian and licensed U.S. military types. During the Cold War, Japan produced licensed fighters such as the F-86 Sabre and F-104 Starfighter for the JASDF.
The Mitsubishi F-2, a joint project with the U.S., introduced advanced avionics, larger wings, and multi-role capability.
Post-war, Japan shifted into maritime defense, producing amphibians like the Shinmus PS-1. The Shin-Meiwa US-1A followed, designed for search and rescue, capable of short takeoffs and landings on rough seas.
The Shin-Meiwa US-1A followed, designed for search and rescue, capable of short takeoffs and landings on rough seas. Its successor, the Shin-Meiwa US-2, entered service in the 2000s, featuring modern avionics and pressurization.
Besides SAR, the US-2 supports humanitarian relief, medevac, and amphibious reinforcement across Japan's vast island chain.
Powered by 4 Rolls-Royce AE2100 turboprop engines, it delivers excellent reliability, endurance, and performance. Powered by 4 Rolls-Royce AE2100 turboprop engines, it delivers excellent reliability, endurance, and performance.
Unique boundary layer control technology enables extremely short takeoffs and landings, even on rough seas.
Capable of operating in sea states with waves up to 3 meters, it can reach survivors in extreme maritime conditions.
Capable of operating in sea states with waves up to 3 meters, it can reach survivors in extreme maritime conditions.
Good.
The aircraft accommodates around 20 survivors, medical staff, and rescue equipment, making it invaluable for humanitarian aid and disaster relief.
The Mitsubishi F-2 is Japan's indigenous multi-role fighter, developed jointly with the U.S. during the 1980s-1990s. Conceived as a replacement for the aging Mitsubishi F-1, with greater range and payload for maritime defense. Conceived as a replacement for the aging Mitsubishi F-1, with greater range and payload for maritime defense.
based on the F-16C/D Fighting Falcon but redesigned with a larger wing, longer fuselage, and advanced composite structure.
It became the first fighter in the world to field an AESA radar, enhancing detection, tracking, and resistance to jamming. Optimized for Japan's geography, it excels at long-range anti-ship warfare, carrying ASM-1/ASM-2 sea-skimming missiles. Production ran from 1996 to 2011, with a total of about 98 aircraft delivered to the Japan Air Self-Defense Force.
Japan Self-Defense Forces JSDF operate the Bell Boeing MV-22B Osprey, marking the first international adoption of the tilt rotor.
The MV-22 combines vertical takeoff or landing like a helicopter, with airplane-like speed and range, for rapid island mobility.
The MV-22 combines vertical takeoff or landing like a helicopter, with airplane-like speed and range, for rapid island mobility.
Deployed primarily with the Amphibious Rapid Deployment Brigade, FISN, modeled after U.S. Marine Corps expeditionary units.
The Osprey enhances troop transport, logistics, and humanitarian missions, quickly moving personnel or supplies across Japan's islands.
The Osprey enhances troop transport, logistics, and humanitarian missions, quickly moving personnel or supplies across Japan's islands.
MV-22s support humanitarian assistance and disaster response, critical in earthquake and typhoon-prone Japan. The MV-22 provides Japan with the ability to rapidly reinforce island garrisons, a crucial factor in modern maritime defense.
Its deployment boosts U.S.-Japan defense cooperation, as both forces share training, tactics, and interoperability in amphibious operations.
The M1A1 Abrams main battle tank is built by Chrysler Defense and replaced the M60.
Look at that amazing engine can go into play.
The Abrams weighs almost 68 short tons, and is one of the heaviest tanks in service.
Maintainers prepare to lower a turbine engine into the tank.
Slow and steady progress ensures no limbs are trapped by the huge motor. After carefully aligning the engine, maintainers guide it onto its mounts. A crane operator controls the lifting and movement, while maintainers call out instructions.
All right, careful. Almost there.
Engine inlets feed a turbine that creates power in the same manner as a jet aircraft.
Engine inlets feed a turbine that creates power in the same manner as a jet aircraft.
The Abrams rolls out onto the proving grounds for a function check.
The tank's turret can move independently of the hull while driving, allowing fire in any direction.
The targeting systems and crew training allow the M1A1 to fire accurately while moving.
In addition to the main gun, the M1 carries additional anti-personnel and anti-armor weapons.
In addition to the main gun, the M1 carries additional anti-personnel and anti-armor weapons.
Fire when ready. Target acquired.
Tank crews practice with both the coaxial and pintle-mounted 7.62mm machine guns.
Confirming all pre-flight checks are complete. Roger that. All systems appear to be nominal.
At full capacity, a KC-135 Stratotanker takes off with 202,000 pounds of fuel aboard. At full capacity, a KC-135 Stratotanker takes off with 202,000 pounds of fuel aboard.
The Stratotanker is the Boeing 707 airframe with various modifications.
The Stratotanker is the Boeing 707 airframe, with various modifications.
The two aircraft have to match an airspeed of 300 knots to refuel. Disconnect. Response, Sergio the Dino 4 Continental South.
With the KC-135, the boom operator has to keep flying the boom during contact.
Braking contact is always down and backward for the receiving aircraft.
This is Reaper 1, we're ready for pre-flight.
Roger that. Initiating pre-flight checks.
During pre-flight testing and checks, the crew chief is in contact with the pilot in the ground control station.
As systems are checked, the crew chief verifies how various systems are responding to the pilot's inputs.
For flight operations, the MQ-9 Reaper relies on its pilot and sensor operator to fulfill its mission. For short-range control of the Predator, it is controlled by a C-band line-of-sight radio signal.
Once the pilot is ready to start the taxiing process of the MQ-9, its wheel chocks are removed.
Once the pilot is ready to start the taxiing process of the MQ-9, its wheel chocks are removed.
Taxi to runway 4.
Copy that, taxiing to runway 4.
An MQ-9 takeoff is approached by pointing the unmanned aerial vehicle UAV down the runway before increasing thrust. An MQ-9 takeoff is approached by pointing the unmanned aerial vehicle UAV down the runway before increasing thrust.
While the pilot is responsible to fly and monitor the Reaper systems, the sensor operator does everything else.
MQ-9 Reapers can fly for up to 40 hours and have a service ceiling of 40,000 feet.
Keep an eye on that signal, we're almost there.
Copy that. Maintaining visual on target.
Because of the GCS, the pilot and sensor operator can access resources not available to a pilot in a cockpit.
So we're just going to go straight for target?
Yeah. Yes, that is correct.
Weapons away. Confirmed.
For long-range missions, the Predator is controlled by a dedicated Ku-band channel, until it is close enough for C-band again.
Marines load through the crew entry door on the front left of the aircraft.
The loadmaster checks the aircraft equipment to ensure a safe exit.
Approaching the drop zone, the jump master prepares to give the signal.
Approaching the drop zone, the jump master prepares to give the signal.
Come on, let's go!
Jumpers make final checks in preparation to exit, waiting for the light to turn green.
Static lines are hooked up to the overhead cable, which will pull their parachutes as they exit. Follow TDA on Facebook and Twitter.